Primary and secondary alcohols can be converted into alkyl chlorides using thionyl chloride, SOCl2, and pyridine as a non-nucleophilic base. And so since this is thionyl chloride, we are specifically taking an alcohol and making it into an alkyl chloride in this reaction. And the substitution part, where we actually replace this oxygen with the chloride, is an SN2 reaction. And so this is restricted to primary and secondary alcohols. So we've got a simple example up here. I'm going to go ahead and draw a secondary alcohol that has a chirality center so we can focus on what happens to that chirality center in this SN2 reaction. So I'm going to draw a small alcohol that has a chiral center. So there we go. And so if this reaction takes place with thionyl chloride, I'm going to draw the structure of that. So we've got a double bond to oxygen from that sulfur, and then we've got bonds to chloride ions as well. Okay. And so what we have then is we've got a electrophilic sulfur, and we have a nucleophile, which is the oxygen of the alcohol. And so what's going to happen here is the alcohol attacks this sulfur, and this pushes these pi electrons up onto the oxygen. And so I'm drawing this mechanism differently than what your textbook shows, but what your textbook shows is not the same as what any other textbook shows, and I don't think it's accurate. Nonetheless, you don't need to know this mechanism, you just need to be able to predict the products and see what happens with the stereochemistry. But I like to run through the mechanism so we can see what's going on here. So again, the oxygen does a nucleophilic attack on that sulfur, and that pushes those electrons up onto the oxygen. You will see a lot of reactions like this in the second semester of organic chemistry when we look at the chemistry of carbonyl-containing compounds. So it's a little bit of a preview of that. Okay, so what we've done, so we've still got that chiral center. The oxygen still has a hydrogen on there. And now it's got a bond to sulfur, and that sulfur has a bond to oxygen, right? Just a single bond now, and a negative charge because we put an extra pair of electrons on there. And we've also got the two chlorines still attached to that sulfur as well. And the oxygen that we started with from our alcohol now has a positive charge. And so what happens next is we're going to reform the double bond here. So one of these pairs of electrons is going to come back down to form a sulfur-oxygen double bond again, and one of those two chlorides is going to be pushed off, and that will be the chloride that's going to come back around and join to form the alkyl chloride. Okay, so what we have after this step then, so we have a bond to the oxygen. That oxygen still has a hydrogen, has a sulfur that has a double bond to oxygen, and another chloride on there. And we do have a positive charge on this oxygen, and this is where the pyridine comes into play. So pyridine is this structure, and so this is often used as a non-nucleophilic base, so we don't want this to compete and try to do an SN2 reaction. We just want it there to, in the solution, to take the acidic proton, and so that's what it does. Okay, so we remove that acidic proton. And so now what we've done overall, so our oxygen has a bond to the sulfur, which also has a bond to the chlorine. And so what we've done overall is we have converted a really poor leaving group, which is OH, because if that were to leave, it would leave as a hydroxide ion, and strong bases are not good leaving groups. So we've converted a poor leaving group into a really good leaving group. So that's what this structure is a good leaving group. Okay, and so since we have a good leaving group, now we can have that SN2 reaction take place. So the chloride that we liberated in that first step can do the SN2 attack. And so if this bond is going into the plane of the page, that means the chloride is going to approach from the opposite angle. So it's kind of coming down from the top of the page, and it's going to displace this good leaving group. And so what happens here, these electrons are going to come in here, so I'm forming another sulfur-oxygen double bond, and we're also pushing off the chloride. And so that's how that leaving group kind of breaks down as this reaction goes. And so we will see Again, the SN2 attack. So what that's going to do is that's going to invert the chirality. And I'm going to draw the byproducts here. So SO2, so sulfur dioxide, that's a gas. So forming a gas always helps to kind of pull a reaction forward, and you're forming some chloride ion as well. Okay, and so overall, we have taken an alcohol, we have made an alkyl chloride, and so the alkyl chloride now can undergo further substitution or elimination chemistry if that's what we're looking for. And specifically, we've also, because it's an SN2 reaction, we have seen inversion of that chiral center. So we see inversion of chirality if this reaction happens to take place at a chiral center.